Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the first module of this course, that is the introduction module. The idea behind this module is to give you a basic introduction to operating systems. So we are already done with the first topic of this course, that is computer hardware review. So in that topic, we went over the computer hardware concepts and understood how each of the individual components, that is CPU, memory and IO devices work. So now that we have a good understanding of the computer hardware, we can start talking about the operating system. So let us start the new topic, that is introduction to operating systems. So in this topic, we are going to understand what is an operating system through a series of videos. In the first video, that is what is an operating system, I am going to give you a bird's eye overview of what does an operating system do. So without further ado, let's get started. So let us start the discussion with the definition of an operating system. So what is an operating system? As you can see, it's a special piece of software that manages the computer hardware, right? So as you can see, this is the compute stack, and the compute stack is a view of the computer system where we say that the computer is organized as a stack of multiple layers. So at the very bottom, there is the hardware, right? These are the hardware components, the CPU, memory, and the set of IO devices. So these make up the hardware layer, right? Then there is the hardware interface. Over this hardware interface, there are multiple layers of software. So the lowest level of software that runs on the computer hardware directly is the operating system, right? So the operating system is often said to run on bare metal. So by bare metal, we mean the hardware interface. So as you can see, the user applications, the computer programs that we launch, these applications are not allowed to directly interface with the hardware. They are based upon the operating system, and it's the operating system that runs on the hardware directly, right? So it is responsible for managing the computer hardware. So we have a definition for operating system, that is it's a special piece of software that manages the computer hardware. So now, first of all, before we talk about how does the operating system manage the computer hardware, we need to understand why does the operating system need to manage the computer hardware in the first place. So let us understand some of the reasons why the operating system needs to manage the computer hardware. So one of the reasons why does the operating system need to manage the computer hardware is that this hardware interface that the hardware exposes, it is very complex to program. So when I say it is complex to program, I mean that if we as software developers have to write our programs over this hardware interface, then it would be an exceedingly challenging job. So what the operating system does, it creates another interface, that is the operating system interface or the system call interface, about which we will be studying in the upcoming videos. So this interface is much simpler than the actual hardware interface, and this can be used to write our programs, right? So this is one of the first thing that the operating system does. It simplifies the hardware interface. So let us understand with an example and see the complexity of the hardware interface. So let us take an example and understand why do we say that the hardware interface is complex, right? So we'll take the example of IO devices. So this slide just recaps how the IO devices are organized. So there are two parts to an IO device. First is the device itself. So let us take the example of the hard disk. So here is the hard disk, that is the device itself, and associated with the disk is the disk controller, right? And there are two connections. The first one is where the device connects with the device controller, that is called the device port. So these ports are at the periphery of the computer system into which you plug in the device cables. And the second connection is inside the computer system. It's hidden in the computer casing. So this is where the device controller connects with the bus, and this is called the device controller interface. And within this interface, there is a set of registers, and the operating system communicates with the device controller using these set of registers. So all communication and all commands are given by the operating system via these registers. So the operating system will read or write these registers to give commands, to check the status, right? All of the communication happens via these set of registers, and these set of registers can become a source of problem. Let us see how. So now let us understand the complexity that is there when we are using the device controller interface. So here we have a hypothetical computer. There are three storage devices, right? there is the disk, then we have the USB controller, and finally we have the CD-ROM. And as we know that storage devices come in the form of IO devices, right? So with each storage device you have the device controller, and the device controller is a very specific chip. It has been designed to control a single device, right? That means that the disk controller can only control the disk. It cannot control any other device, which that is, the device controller is a very unique chip. Hence the interface that it exposes, that is also very unique. So as you can see, each of these three different device controller has a unique interface, right? And when we say unique interface, we mean the set of registers that is there in the interface, that is totally unique. Now here lies the problem. So now all of these storage devices are used for one single thing, that is to read or write data persistently, right? Now imagine you're writing a program for reading or writing data from these storage devices. Then the problem is that for doing the same thing, right, for accomplishing the same task, you will have to deal with three different sets of registers, three different device controller interfaces, and this is very non-intuitive and counterproductive, right? And this is not the only problem. Let us see another problem. So this is the interface that the device controller exposes to the layers of software above. For any storage device, it is a sequence of blocks where the blocks have their block addresses, right? So as you can see, there are three types of devices. There is the disk, USB, and CD-ROM. For each, there is a different block structure, the number of blocks, the block sizes. So all of these are different. So when you're writing a program, you'll have to write three different pieces of code to handle all of these differences. And finally, when you're writing program at this low level, then let's say you're writing a program to store your data, then you have to know exactly at which address you have to store your data. And finally, when you're reading your data back, then you have to remember where you had stored your data. You have to supply that addresses. This dealing with block addresses is very non-intuitive, right? So we just want to store our data. We don't want to be messed up in the addresses. So you see how this low level interface, this device controller interface, poses several challenges to the software developer when they're writing their program. So now let us see how the operating system solves these challenges for us. So now let us see how the operating system takes care of the complexity. Basically, in the context of the storage devices, it provides the idea of a file. So as you can see, as we know, basically when we store our data on storage devices, we do it in the form of files. So file is basically a logical unit where we store all of our related data. So here we have three files, right? One is a text file, then we have an image, and finally we have a video file. So basically a file is a logical unit where we can store all of our related data and we give it a name. So this idea of a file is provided by the operating system, right? At the hardware interface, there is no concept of file. It's the operating system that creates this virtual resource, that is the file. And as you can see, the operating system maps these files to the blocks. So as you can see, the video file has been mapped to the blocks 1 to 9 on the disk. Then the text file is mapped to 15 to 18 on the disk. And when you're now as a programmer, when you're reading or writing your data on these storage devices, you don't have to provide these addresses. So you just have to provide these file paths, which are human readable in English language, right? These file paths you just have to provide. The operating system will map those file paths to their respective block addresses. So now the dealing of block addresses has been shifted to the operating system. You as a programmer are relieved from these low level details of the devices, right? So this is how the operating system solves the first problem, that is of dealing with the low level block addresses. Another thing that the operating system has done is that it has simplified these three different unique interfaces and provided a single uniform interface, right? So when you are dealing with files, it is not device specific, it is device independent. It does not matter where your file is. It could be on the disk or the USB stick or the CD-ROM, but the interface for a file is uniform, right? So this the operating system has done for you, and someone has to still deal with this three different unique interfaces, the sets of registers in the device controller interface, but that has been done for you by the operating system, right? You as a user, when you are using the operating system's interface, is provided with a uniform interface for the storage devices, right? So this is how the operating system has simplified the device controller interface. First of all, it provides a uniform interface, and another thing that we saw is that it relieves us from dealing with this low level block addresses, right? So as you can see how the hardware interface is complex and how the operating system simplifies it. So we wanted to understand why does the operating system need to manage the computer hardware, right? And that is where we said that the hardware interface is complex to use and the operating system simplifies that hardware interface. So from there we get the first responsibility of the operating system. So that is making the hardware easy to use. So as part of managing the computer hardware, the first thing that the operating system must ensure is that the computer hardware is easy to use, and it accomplishes this via the idea of abstraction. So we just saw in the previous slide how the operating system manages the storage devices. So there was this underlying problem of complexity with using the device controller interface of storage devices, and there the operating system provided the concept of a file that made it very easy to use those storage devices. So this is the idea behind abstraction. So what the operating system does is that it takes a physical resource and transforms it into a virtual resource which is easy, much more easy and powerful to use. So this transformation from this physical to a virtual resource is the idea behind the abstraction. So basically you can say the operating system has abstracted out the complexity of the physical resource, right? So we'll see several examples of abstractions when we talk about other types of hardware resources, and see how the operating system provides easy and simple to use abstractions over other hardware resources like CPU, memory, and IO devices. So this was the first fundamental role of the operating system, that is to make the hardware easy to use. So now let us look at what is the next responsibility of the operating system. So we'll try to understand why does the operating system need to manage the hardware. We'll see the second reason and finally get to the second responsibility of the operating system. So now let us try to understand another reason why the operating system needs to manage the computer hardware. So the first reason we have already seen is that the hardware interface is complex to program. That is why it needs to be managed by the operating system. So the operating system tackles this problem by making the hardware interface easy to use. So this was the first reason. The second reason, let us try to understand. For that, I have modified the compute stack diagram. As you can see, I have removed the operating system from the picture. So basically now the user applications are running directly over the computer hardware. They have the they have the control of the computer hardware. So now the thing is that a computer system has a lot of hardware resources. There is the CPU, then we have the memory, and then we have a set of IO devices. All in all, a computer system has a lot of hardware resources, right? Now, the second point is that user applications. It is the user applications that define how these computer hardware resources are used. So if you see carefully, each of these user applications is trying to solve some computing problem, and different user applications will be trying to solve different computing problems. So for example, there is the web browser which is trying to solve the problem of helping the user to surf the internet. Then we have the word processor that helps the user to create digital documents. Let's take one more example, that is of media players. So they decode different audio and video formats and help the user to play the media files. So you can see different user applications are trying to solve different computing problems. But the common thing about all these user applications is that they will use the same set of computer hardware. All of them will use the computing power, the memory storage, and use the IO devices to interact with the user. So no matter what the user application is trying to do, which computing problem it is trying to solve, all of these applications will be using the same set of computer hardware, right? So this brings us to the next point, is that all of the user applications need these hardware resources. Each application needs the CPU, they need the memory, and the IO devices. So the point is that in a computer system we have a single set of resources, but there are several user applications, which means that these hardware resources are shared by all the user applications, right? and these are limited in nature. It is not the case that we have unlimited compute power or unlimited storage. So these are resources which are shared and limited in nature. That is why they have to be managed and allocated carefully, right? So we need a entity that does this job of managing these hardware resources. We cannot leave the hardware resources directly to the control of user applications. So we need a third party or an intermediary who will ensure that all of these resources are managed properly and allocated to the user applications. So that is why we bring the operating system again into the picture. So let us talk about how the operating system manages these hardware resources. So in the previous slide, we said that all these user applications require these hardware resources, right? So all these hardware resources are shared by the user applications, and not only that, they are limited in nature, right? So there is a need that all these hardware resources are managed carefully and used efficiently, because otherwise there are several user applications and the requests for resources that will be coming from them, it would be difficult to satisfy them. So there is a need to carefully and efficiently use these resources. So that is where the operating system helps us out. It acts as an intermediary between the user applications and the hardware resources. So all the requests for resources have to go through the operating system. So it's the operating system who is aware of all the hardware resources, that is, it keeps track of them, how much is available, how much is in use, and whenever there is a request from the user application, it examines that request, and if it is valid, if it is proper, then only it approves that request. So this is how the operating system acts as a safeguard against the misuse of the resources, right? It could be the case that if we don't have the operating system, then maliciously written user application can monopolize over the resources of the computer system. In that case, the other user applications won't be able to run, right? Because some user application has hogged over the resources of the system. So apart from ensuring that the resource allocation is fair, the operating system also ensures that these resources are utilized, like there is a proper utilization of these resources, that they do not remain idle. So it ensures that all of these resources are busy, and in this way you can see how the operating system makes sure that the hardware resources are used efficiently. So this is the second way in which the operating system manages the hardware resources, right? So this brings us to the second fundamental responsibility of the operating system, that is to make sure that the hardware is used efficiently, and that it accomplishes by doing a careful resource management. So there are several hardware resources in the computer system, and the operating system keeps track of each of them, and it knows how much is available, how much is in use, and whenever there is any request from the user application, it examines those requests and carefully does a resource allocation. It has to make sure that all the resources are fairly allocated, the resource utilization is high, and so on. So a proper resource management is very crucial in the computer system, and that is accomplished by the operating system. So the operating system is also known as the resource manager. So let's quickly summarize what all we have learned till now. So I started the video with the definition of the operating system, that it is a special piece of software that manages the computer hardware. Then we raised the question that why does the operating system need to manage the computer hardware? And then we saw two major reasons. The first one is that the hardware interface is too complex to program, and the second reason is that the hardware resources are shared by all the computer applications, and moreover they are limited in nature, so they have to be properly managed and allocated, right? So this gives a rise to the two fundamental duties that the operating system performs in the computer system. The first one is to make sure that the hardware interface is easy to use, and that it accomplishes by providing powerful and easy to use abstractions. And the second role of the operating system is to make sure that all the hardware resources are used efficiently, right? And that it makes sure by doing a careful resource management, right? It keeps track of all the resources, and whenever there are requests from the computer application, it examines them and approves them properly. So this gives you a clear idea of what the operating system does, what it is, and what are its roles. So now let's see some more points about the operating system. The next point about the operating system is that it runs on the bare metal and provides the base for all other software, right? So as you can see, this is the compute stack, and we have different layers. At the very bottom, you have the computer hardware. and this is the hardware interface. And the first layer of software that runs on this hardware interface is the operating system. That is why we say that the operating system runs on bare metal. So as you can see, no other piece of software is directly running on the hardware interface except for the operating system. In this way, it is a special layer of software, right? And upon this operating system, all the other pieces of software are based. So as you can see, the user applications are based on the interface that is provided by the operating system. It's the base for all the other pieces of software. The next point is a very interesting one. It says that the operating system acts as a government that governs the computer system. So basically, I have a very interesting analogy for you. And the analogy is that whatever role the operating system plays in a computer system, which is very similar to what a government does in an urban environment or urban city. So let us see how these two roles are very similar. So you can see this is the computer system, and we have hardware resources which are managed by the operating system for the computer applications. Now, this is something very similar to what a government does in a city. So I have a diagram for this. So just like the compute stack, this is a diagram for the different entities in a urban city. At the very bottom, there are the resources that are required by all the citizens who are living in the city. So these are like electricity, water supply, the transportation networks, and just like the computer applications in a computer system, at the very top, we have the citizens or the people who are living in the city. And what I'm trying to say is that whatever the operating system, the role, basically not whatever role the operating system is playing in the computer system, it is very similar to what a government does. So let us see how these two roles are similar. So just like the computer system had the hardware resources, which was managed by the operating system, my point is that these resources which are needed by all the citizens of the city, the electric supply, the water supply, the transportation networks, these are resources of the city which are managed by the government. And we saw that the fundamental responsibility of the operating system was to make these resources, hardware resources, easy and efficient to use. So in a similar manner, let's see how the government makes these fundamental resources of the city easy and efficient to use for the citizens. So let us now see how the government makes it very easy to use these resources. For example, let's talk about the electric supply. So the electricity is produced is some power plant, that is thermal power plants or hydroelectric power plants, and these are situated outside the city. Now, if the government does not do anything for distributing that electricity to each of the homes, then it would be very difficult for the citizens to use electricity, right? So in that case, every citizen would have to figure out themselves how to fetch that electricity from the power supply to their local homes. Instead, fortunately, what the government does is that it creates a distribution channel for the power supply, and now we as citizens just have to tap to the nearest power line, and that is how we can get the electricity into our homes. The actual work, that is the laying of distribution network and its maintenance, is taken care of by the government. So you see how the government makes it very easy to use the power supply, that is the electricity. Let's take example of another resource, that is the water supply. So the water in our cities comes from rivers and lakes, and there has to be a distribution network. Just like the electricity, we need a water supply system. Again, it is the government who makes and manages these water supply systems instead of the individual people of the city doing it, right? If the government does not do it, then imagine how we have to manage the water supply to our homes ourselves, right? So it would be a very difficult job. So currently what we need to do is that, just like in the case of electricity, we just need to tap to the nearest water pipeline and we will get the water into our homes. So this supply system that the government manages has made it very easy for us to use the water supply. Let's take one final example. The final resource that I want to talk about is the transportation systems. So the transportation networks are shared by all the citizens in the city, and the government basically takes the responsibility of laying out the roads, making the highways, making the railway tracks, managing the air traffic. So all of these complex tasks are taken care of by the government, and we as citizens can just go ahead and use the transportation networks. So you see how the government makes it very easy for us to use these very important transportation systems. So you see, I talked about several resources: the electricity, the water supply, the transportation systems, and how the government makes it very easy for the citizens who are living in the city to use these resources. This is something very similar to what the operating system does in a computer system. It takes the hardware resources and makes it very easy for the computer applications to use those hardware resources. Apart from making the hardware resources in the computer system easy to use, the operating system also ensures that these resources are used efficiently. So that is something that the government also does. So as you can see, these are resources that are required by all the citizens in the city. So these are shared in nature. Also, these are precious resources which are limited. It's right. So they have to be used properly. So what the government does to ensure that they are used efficiently, it puts a charge on these resources. So for the amount of resources that you use, you have to pay an appropriate charge, right? This prevents the citizens from misusing the resources or using as much as they want. They have to pay for what they are using. And it's not just the money, the government also puts laws and regulations so that even if you want to pay, you cannot use more than a certain amount of resources. So these are resources that are essential for all the citizens and have to be managed carefully and ensure that they are used efficiently. So that is something that the government does, right? So you see the two fundamental responsibilities that the operating system plays in a computer system, that is, it makes sure that the hardware resources are easy and efficient to use for the computer applications. The same thing, something similar, the government is also doing in the urban environment. It is taking all the resources like the common necessities like the electricity, water supply, transportation system. It ensures that all of these resources are easy and efficient to use for the citizens who are living there. So guys, this was it for this video. In this video, we defined the what is an operating system. That is, it is a special piece of software that manages the computer hardware. We saw the reasons why the operating system needs to manage the hardware, and accordingly, we came up with the fundamental responsibilities of the operating system, that is to make the hardware easy and efficient to use. And we also discussed an interesting analogy about the operating system and the government, that is how they play similar roles in their respective environments. So this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.